Welcome to this session on differentiation rules. The previous time we did differentiation from first principles and we saw that it's quite a long process. But there is a quicker way to do it, and that's what we're going to look at today. We're going to start with this example on the board. Fx is a half x to the 5 plus the cube root of x to the 7 plus 4 over square root of x plus pi times x plus square root of 13. Okay, so we should cover the most important examples in this sum. On the right hand side there's a short summary of the differentiation rules, and you can refer to that as we go along. So the first thing we do is to change all the square roots into the exponential form, and any terms underneath the fraction, so in the denominator, needs to become a numerator. Okay, so half x to the 5 plus x to the 7 to the power of a third plus 4 over x to the power of a half plus pi x plus square root of 13. We don't change the square root of 13 because it is a constant. So this then becomes a half x to the 5 plus 7 over 3 x to the 7 over 3 plus 4x to the negative a half. Okay, we take the x to the power of half to the top, and therefore the sign of the exponent changes. Plus pi x plus square root of 13. Now we have it in the right form. No terms below the line, x is below the line, so now we can apply the rules. So we take the exponent, we times it by the coefficient and subtract 1 from the exponent. So that would be 5 over 2 x to the power of 4 plus 7 over 3 x to the power of 7 thirds minus 1 will give us 4 thirds. Now minus a half times 4 is minus 2 x to the power of, now if we subtract 1 from minus a half we get minus 3 over 2. 1 times pi is just pi, x to the power of 0 is 1, and the constant disappears. The reason it becomes 0 is the gradient of a constant is 0. Okay, so these are the differentiation rules. The next thing I'm going to look at is notation. So we know about f dash x, d dx, there's the dx and y dash. And we want to know when we're going to use each of that. Okay. Obviously, if we get something like fx equal to 1 over 5x to the 3 minus 2x squared plus 7x minus 3, we will use f dash x. We don't want to complicate things, which will give us 3 over 5x squared minus 4x plus 7. Now if we want to know the maximum value of, let's say, an expression, so if I get something like 3x to the 2 minus 6x plus 13, and we want to know what the maximum value of that expression will be, we will just use dx, Because there is no y, so we can just say dx of that, which will give us 6x minus 6, and that's it. Okay. Then, if we have something like, if it's a function but it's written as y equal to, and it's going to be, let's say, 3x to the power of a third minus 7x, we can say the y dx is equal to x to the power of minus 2 over 3, because a third minus 1 is minus 2/3, minus 7. Now the last one we don't use very often, but it would be in a simple example like this, where we could say that's also y dash. Thank you very much.